So today we're going to get into graphs of the sine and the cosine function, phase shift. Here's the official look at that. So it'll introduce you to the visual look of the sine and the cosine functions. And what we'll do is we'll get key points. I like to do this with a blank slate initially here. And so let's look at what the sine looks like. So let's go ahead and let's do sine of x, and let's put a bunch of points and graph the sine function here. So y equals sine of x. So let's say we plotted some points. Let's say we throw in 0, and of course I'm looking on my unit circle, right, at 0. If I don't rotate at all, what's my sine value there? I say, well, the sine of 0, the y value there, 0 is 0. I get that. Now let's do pi sixth. We'll throw in these key points. So let's go to the next spot on my unit circle at pi sixths. I rotate pi sixths amount. I get that spot on my unit circle, root 3 over 2 comma half. I find the sine of pi sixths. Again, pi 6 is my input. Sine of pi sixths is the y value there. So 1/2. So pi 6. So far we got 0, 0. Here, I'm going to cut this into fourths here. Let me do this. I'm going to go up to 2 pi, so one whole revolution around. So I'm going to go up. But I'm going to cut this first from pi 6. I'm going to plug in pi 6. Then I'm going to plug in pi fourths. Then I'm going to plug in pi thirds. Okay. Well, pi 6 gave us a half. So let me put that point on there, pi 6 a half. And then I'm going to punch in pi fourths, the next spot on my unit circle, right? If I rotate 45 degrees, or pi fourths, the sine there is root 2 over 2. Root 2 over 2, that's like, was that like 0.7-ish, I think. I find out what that is. I plot it on my graph. Now I'm going to go to pi thirds, and then I'm going to go to pi halves. So now I do pi thirds. What's the sine of pi thirds? Root 3 over 2. I put that point on, a bit higher. And then finally I take the sine of pi halves. Well, if I rotate 90 degrees at the point 0, 1, the sine of pi halves is 1. Okay, so far I've got this. I could connect my dots, right? I could plug in some more with my scientific calculator if you wanted to, but I'm just using some key points from my unit circle, right? And then I can keep going with that. Here, let me erase a little bit of this. So I could punch in 2 pi thirds, be another one. It'd give me this point. I could punch in 3 pi fourths, be another one, give me that root 2 over 2, and so on. Anyways, until I get to pi. Sine of pi, that's another good one, right? That's I've rotated 180 degrees. I'm right here. The sine of pi is 0. So I have the point pi comma 0. And I graph all these points. That's supposed to have some nice curvature to it down to there. Sine of pi is 0. And then I'm going to skip to 3 pi halves, or 270 degrees. So I rotate 3 pi halves, and I find that my sine there is -1. Sine of 3 pi halves, so I plug in 3 pi halves. I find the sine of 3 pi halves is -1. Again, I can plot all those points in between. And then I'm going to go back till I get to 2 pi at least. I'll do that key point. Sine of 2 pi, so I go all the way around. Sine of 2 pi is 0. So I have the point 2 pi comma 0. Remember, pi is pi is 3.14, so that's like 6.28, right? But I'm doing this graph, I'm doing a trig graph, so I'm going to do it in terms of pi here. All right, so I've cut, and this is one revolution of sine. I could keep going with this. I could also plug in some other points. many points as I needed till I see this thing, like negative pi halves, for example. And if I rotate negative pi halves, the sine of negative pi halves is negative 1. I put that plot on there, and then I'd graph the sine of negative pi, which is 0, and then I'd plot the sine of negative 3 pi halves, which is 1. I'd plot the sine of negative 2 pi, which is 0, and so on. And I'd get another revolution of this. See how that's that same wave right there? Okay. So this keeps going. So what I'm showing you from here to there is one cycle or one period. So the period is 2 pi. And see how it repeats that same thing? Let me do it in red here. See, and it takes a distance of 2 pi to do that, right? So the period is 2 pi. There's another term I want you to be aware of, and that's called the amplitude. The amplitude is half the distance. The amplitude here is 1. It's half the distance from high to low. So can you see how you're as high as 1 and you're as low as negative 1? Well, that distance is 2. From 1 to negative 1, that's a distance of 2, but the amplitude is half that distance. The amplitude is half the distance from its highest point to its lowest point. So the amplitude for the sine function is just 1. Okay, so this is what the sine curve looks like. And we would do similar for the cosine function, but now we've got to find cosine values. So let's go ahead and do that. The cosine function now. What does the cosine look like? And let's plug in some key points as well. 0 pi halves, pi, 3 pi halves, 2 pi, and so on. And then we throw in 0. All right, cosine of 0, so I'm on my unit circle. Cosine of 0 is 1, the x value there. So I got the point 0, comma 1. I'll put that point on there. Now let's throw in pi halves for the x here. Cosine of pi halves. So I've rotated here. Cosine of pi halves, right? I've rotated pi halves here. Cosine of pi halves is 0. So I got pi halves 0. Now let's go to pi. Cosine of pi. So now I've rotated pi. I'm right here. Cosine of pi is negative 1. So I got the point pi comma negative 1. Now I rotate 270 degrees. I find that the cosine of 3 pi halves is 0. And then I go back all the way around and I find that the cosine of 2 pi is 1. Okay. And this shows one cycle. Now I could keep going, but I'm just going to draw this one. So you can see it's going to repeat this. This is the same, has the same distance for the period. It's still 2 pi. Now let me put some more points on. And this will repeat. Oops, I didn't leave myself enough room. Oops, that's 4 pi. What am I doing? And hopefully you can see, hey, that's the same, right? You could do it over here as well, but it takes 2 pi to do that. Now, one other look at this, well, and also I should mention this amplitude is also 1. Right, it goes from a high of 1 down to a low of negative 1. So half that distance, half the distance of 2 is 1. Okay. Can you see how they're the same curve, but they're shifted over? So if you shifted the cosine, if you took the cosine right here and you shifted it over, pi halves amount, you shifted it over, can you see how you would have, See how you'd have the same as the sine, right? It's the same curve, right? It's shifted over. So that's plotting these with some key points. And there's your look at it. The graphing calculator, which you could also take a look at. Well, let's do some. Now let's talk about the general forms of these. Okay, so the general form of the sine is y equals a sine bx minus c, and I'm going to add on a plus d. This will be your vertical shift, up or down. Okay, this phase shift, this will be your horizontal movement. So horizontal movement as well as stretch and compression on this. And the period is based off of the b, so the period is also always 2 pi over b, and the amplitude comes from the a values, the absolute value of a. So the amplitude will affect your vertical stretch. Okay. So let's look at this first one here without graphing. A sine bx minus c plus d. So number one, what's the amplitude? Well, the amplitude is the absolute value of a. In this case, can you see how the a is that negative 3.4? So it's the absolute value of negative 3.4. So there's our amplitude. Okay. So in other words, it goes as high as 3.4 and as low as negative 3.4 because it hasn't been shifted up or down. Right? So that's so the amplitude, half the distance from high to low. A period. How long does it take to complete one cycle? 2 pi over the b value. Well, the b value here is 5. So this is 2 pi over the 5. So it takes 2 pi fifths to complete one cycle. Whereas the regular sine function takes 2 pi to complete one cycle. So this has been really compressed and stretched out. So it does it really quickly. It only takes 2 pi fifths to do that. Okay, again, that's not an accurate drawing, but I'm just showing you that that's compressing it. That's a horizontal compression on that. And that's because the k value, if you remember from your transformations, in fact, this is probably a value to make a note. Okay. If you have f of kx, this will be a notes on transformations from Math 126, from Pre-Calc 1. If your k is bigger than 1, that'll be a horizontal compression. If your k is less than 1, greater than 0, that'll horizontally stretch it out. You'll see that. We'll do some graphing with these. You should also note if you throw a negative x in for the x, that'll reflect it about the y-axis, right? Whereas if you put a negative out front of it, it'll reflect it about the y-axis. That's a few transformations to remind you about. Okay. All right, let's go back to this. So we did the amplitude, we did the period, and then we want to find our phase shift is the last thing. Our phase shift is c over b. And hopefully you can see the c here is 7, and our b here is the 5. So our phase shift is 7 fifths on this one. Okay, let's do another one down below. This would be a good time to have this be a you try it problem. Good time to pause the video and try it yourself. All right, so number one, our amplitude here, whoops, amplitude is the absolute value of A, so that's the absolute value -1/5, whoops, which is 1/5. Number two, our period here is 2 pi over b, so hopefully you can see that the b here is pi halves, so this is 2 pi over pi halves, so I got dividing by a fraction here, so I'm going to multiply by a reciprocal, right? So times 2 over pi. So we got 2 pi times 2 over pi. See how the pi's cancel? We're just left with 4. So our period here is 4, right? So this is saying, whoops, what did I do? This is saying, again, this is not exactly what it looks like, but it just takes 4 to do one cycle. Whoops, I didn't draw that right there, but the idea. All right. As our period, let's do our phase shift. So number 3, our phase shift, which is C over B. Okay, what's our C? Can you see how C follows the minus sign? Right, so it's minus C, but we don't have a minus. We have a plus here. So just be careful on that. You might want to write that. That's the same as minus a -2/3. So can you see how C is actually -2 pi thirds? That's your C. Your B is the pi halves. And you just got to clean that up. So times 2 over pi. Pi's cancel, so it looks like our phase shift here is -4/3 is our phase shift, and I'll talk about what that means here graphically when we get to a phase shift. Okay. All right, let's keep going here. So here we got the 4 sine of x. Let me write this. So we got 4 sine of x. So number one, I would note my amplitude. Remember, y equals a sine bx minus c plus d, right? The amplitude is just the absolute value of a. So the absolute value of 4, which is 4, okay? Number two, my period is 2 pi over b. And you can see the b is the number in front of x. So there's a 1 right there that they don't show you. So it's just 2 pi over 1. So it's just 2 pi. Our period is 2 pi. And number 3, let's do our phase shift. Our phase shift is c over b. Well, there's no c, right? In other words, it's minus 0. So the c is 0 over our b of 1. So phase shift is just 0. The phase shift is where you want to start. That's the movement right, left. Okay, so but it's a key point where you want to start. You want to start with your phase shift. In this case, it's just 0. So we want to start there. And then the second thing is you want to cut the period into fourths. Okay, so our period is 2 pi. So what's a fourth of 2 pi? Well, that'd be pi over 2. So I want to go up pi over 2 to my next one. So the next spot is 0 plus pi halves is pi halves. The next one after that, pi halves plus pi halves is 2 pi halves. I'm sorry, 2 pi over 2, which is just pi. And then I want to go up another pi halves from that. Well, 2 pi over 2 plus another pi over 2 is 3 pi over 2. So that's the next key point. And then 3 pi over 2 plus another pi over 2 is 4 pi over 2, which is 2 pi. These are going to be my key points on my graph that I want to plug in. So let's throw in the first one. I got 4 sine of x. I'm throwing in 0. 4 sine of 0. So I look on my unit circle. I find the sine is 0. Right, I'm looking on my unit circle. Sine of 0 is 0. So I got 4 times 0. Well, 4 times 0 is 0. So there's my first point. Now I'm going to throw in pi halves, my next point. So now 4 sine of pi halves. So now I'm looking on my unit circle. I rotate to pi halves. Well, the sine of pi halves is 1, and 4 times 1 is 4. So now I have not only the point 0, 0, I'm going up pi halves amount each time. Let me put my marks on here. Pi halves spit out 4. 1, 2, 3, 4. So pi halves 4. Now I'm going to plug in pi. 4 sine of pi. Well, I know the sine of pi. Sine of 180 degrees is 0. Sine of 0, 0. So right there. Now I plug in 3 pi halves. 4 sine 3 pi halves. I know the sine of 3 pi halves is negative 1. So I get negative 4. That one in. And then I find the sine of 2 pi is 0. 0 times the 4 in front is 0. And I graph 1 period. This thing, 1 cycle. Now it does keep going. I'm going to indicate that with my arrows. Okay. So what did this 4 in front do? Well, that vertically stretched it. It vertically stretched the original sine of x. If I was to graph just the sine of x, here's the sine of x. Goes as high as 1, as low as negative 1. See how it stretched that out? It vertically stretched it. So that's what that 4 in front did, right? Stretch that out. So if you can imagine on this next one where we got negative 2 cosine of x, let me go ahead and erase this a little bit. Get a little room here. The negative is going to reflect the cosine function about the x-axis, and because the absolute value of negative 2 is bigger than 1, it's going to also stretch it out. It's also going to stretch it out. Okay, so what you're thinking is, here's my cosine function. Graph it real quick. Oops. It'll flip it around. So here it is flipped around. Whoops, I'm going to do a different color. Flip it around. Here's around the x-axis. Okay, here's y equals negative cosine x. But then I got to stretch it out. So it's going to stretch it out. So I'm going to have an amplitude of 2. So let me do that in black. So it'll actually be more like this. That's what we're expecting to see. Again, these are all by transformations, right? This one is just a transformation of the cosine function. So let's go ahead and graph a few points here. And again, we'll start with number 1, our amplitude is 2. Number 2, remember a cosine b x minus c plus d. So if you can see the number in front of x is 1. So when we're finding our period, 2 pi over b, period is just 2 pi over 1 again, right? So period is 2 pi. The phase shift, the c here, is 0. So we're going to start as 0. We're going to cut the period into 4, so we're going to take 1/4 of the period, which is pi halves, and we're going to go up by pi halves from the phase shift point. So 0 up pi halves is pi halves. Pi halves plus pi halves is 2 pi over 2. 2 pi over 2 plus another pi over 2 is 3 pi over 2. And 3 pi over 2 plus another pi over 2 is 4 pi over 2. And those will all be nice key points that we will plug in one by one to see our graph, and then we'll plug them in. So we got y equals negative 2 cosine of x. Let's throw in the 0. Well, the cosine at 0 is 1. So the first point is 0, negative 2. We plot that point, and we're throwing in pi halves, pi, 3 pi halves, 2 pi, and so on. Let's throw in pi halves now. Y equals negative 2 cosine of pi halves. I know the cosine at 90 degrees is 0. Negative 2 times 0 is 0. So we got pi halves 0. Whoops. Pi, now let's throw in pi, sorry about that. Y equals negative 2 cosine of pi. Coming in a circle at 180 degrees, pi there, cosine pi, the x value there. It's negative 1, so negative 2 times negative 1 is 2. Plug in the 3 pi halves, plug in the 2 pi. Again, this is what that looks like. Alright, hopefully you can see this period here is 2 pi for the cosine function. As we suspected with our reflection and vertical stretch. Alright, so this one we got negative 3 sine x plus 2. So just to get a feel for this, that'll reflect it about the y-axis, it'll vertically stretch it, and it'll bump the whole thing up 2. So if this is your sine function, then we flip it around. That'll be, here's your negative sine. Okay, there's negative sine. Now we're going to vertically stretch it, so negative 3 sine. Let me do that. There's negative 3 sine. And the last thing is, and I want to make a note of something here. Right now my midline, the middle of this is the x-axis. In other words, y equals 0. That's your midline right now. But when I bump the whole thing up to, right, I bump it up to, vertical shift up to, now my midline becomes y equals 2. So the whole thing's bumped up to. All these points up to, and so it goes down, way up, and then ends right there. That's what we're expecting when you graph this thing. That's how you graph it with transformations, right? And we're going to go ahead, we'll plot a few points real quick on that, but you can get a feel for this one with transformations, of course. So number 1, oops, let me actually do this. Y equals a sine b x minus c plus d. Amplitude, absolute value negative 3, which is 3. Period here is 2 pi over b. Our b here is 1. So the period is just 2 pi. And the phase shift, again, our c value is 0, and our b value is 1. So our phase shift is 0. That's where we're going to start. When we plot these points, we cut the period into 4, so 2 pi 4 is pi halves. I'm going to go up pi halves each time. So we've got these same key points again, right, that we're plugging in. We're going to plug them in one by one. So y equals negative 3. Let's plug in the 0. Sine is 0. We know the sine is 0, 0. And 0 plus 2 is 2. Then we're going to plug in pi halves. We know the sine of pi halves is 1. So we got negative 3 times 1 plus 2. Well, negative 3 plus 2 is a negative 1. Remember, our midline, the whole thing got bumped up to, so that's my midline on this thing. So I got 0, 2. Let me put on my pi halves, pi, 3 pi halves, and 2 pi. So pi halves, I've got negative 1. Now I'm going to plug in pi. I know the sine of pi is 0. 0 times negative 3 and from 0. 0 plus 2 is 2. So pi comma 2, so back to that midline. Now I plug in 3 pi halves. I know the sine of 3 pi has -1. Negative 3 times -1 is 3. 3 plus 2 is 5. So I got 3 pi has 5. And then I'm going to plug in 2 pi, and it'll give me 2. So now the sine of 2 pi is 0. And this will take that. Just like that, right? So again, flipped it over, stretched it out, bumped the whole thing up to, and you can see your new midline there in green, y equals 2. So here we've got a different b value than 1. So let me write this: a cosine bx minus c plus d. So you can see how your b value is a half. So that's going to change things. And because that b value, the absolute value of that number is less than a half, it's going to horizontally stretch this out because the 1/2 is less than 1. Is that what I said? If that b value is bigger than 1, then that'll be a horizontal compression. But let's go ahead and run through it. Number 1, what's our amplitude? Well, it's the absolute value of 2. It's 2. Number 2, what's our period? Well, it's 2 pi over the b, so it's 2 pi over that 1/2. So multiplying by the reciprocal 2 over 1, that'll give us a 4 pi. So we're going to cut that into fourths. So the period now, it takes clear until 4 pi. So I've got clear until 4 pi, right, to do this one revolution. Our phase shift here is c. There is no c value over the b. So phase shift is 0. So I want to go ahead and start at 0. But I'm cutting the period into fourths. So 1/4 the period. Well, our period is 4 pi. So 1/4 of 4 pi is just pi. So I want to go up pi. So 0 plus pi is pi. Pi plus pi is 2 pi. 2 pi plus another pi is 3 pi. And 3 pi plus another pi is 4 pi. And those key points, pi, 0 pi, 2 pi, 3 pi, and 4 pi, will give me one nice cycle. It'll show me one entire period. And now I can just go ahead and plot some more points again. So let's plug in 0. Half times 0 is 0. I know the cosine of 0 is 1, the x value there is 1. So I got 2 times 1 is 2. So 0, comma, 2 is my first point. Now I plug in pi. And I got cosine of pi halves. Well, I know the cosine of pi halves is 0, so I got 2 times 0 is 0. So I got pi. I'm going to plug in 2 pi. Well, a half times 2 pi is just cosine of pi. And cosine of pi is -1, so I got 2 times -1, I got -2. So 2 pi, -2. 3 pi is going to spit out 0. 4 pi is going to spit out 2. And you're going to see the one cycle or period. You see how the period here takes you 4 pi. Okay. And do note the domain and range on these. These keep going, right? Like they keep going to the left, they keep going to the right. So the domain on all these is -infinity, +infinity. In this case, my range, the lowest y value is a -2. My highest y value is a 2. So my range here is from -2 to 2. On just the classic cosine that we initially graphed at the beginning, the second graph we did, that just went from -1 to 1. Right. So this has been stretched out because of that 2 in front. It's vertically stretched out, but it's been horizontally stretched out, right? It takes me longer to do one cycle, and that's because of that b value right there, that 1/2. Okay. All right, here we've got 3 sine of pi x. So I'm thinking about a sine bx So you see my B here is pi, right? But let's go ahead and start with our amplitude. Our amplitude is 3, so we are vertically stretched again. Number 2, our period here is 2 pi over B. Well, our B here is pi, so 2 pi over pi is 2. Okay. So we got just a period of 2. Number 3, our phase shift is C over B. Well, our C here is 0. Our B is pi, so our phase shift is 0. We're going to start at 0. And then we're going to cut the period into fourths. So 1/4 of our period. 2/4 or a half. So we're going to go up a half from 0. So 0 plus a half, 1/2. 1/2 plus a half, 2 halves. 1 plus 1/2. And 3 halves plus 1/2 is 4 over 2, or 2. So those are our key points that we want to use for when we're graphing this. So our first would be just at a half, 1, 3 halves, and then 2. And that'll show us one cycle here, right? So a little bit different because our period is just 2, and our period is not 2 pi. Our period is just 2 here, right? So let's throw them in one by one. I got 3 sine pi times x. Well, let's throw the 0 in. I guess sine of 0. Well, I know sine of 0 is 0. So I got 0, 0 for our first point. Now let's throw the 1/2 in. So I got pi times a half. Well, I know the sine of pi halves is 1. So I got 3 times 1 is 3. So 1/2, 3. Then I'm going to throw 1 in. Pi times 1. Well, I know the sine of pi is 0. So I'm back here. Throw in 3 halves, and I'll get the sine of 3 pi halves, negative 1. Negative 1 times 3 in front is negative 3. And plug the 2 in. You can see there's your sine, right? So the 3 has vertically stretched it. And instead of a 2 pi, which is 6.28 period, this period is only 2, right? So this pi, because pi is bigger than 1, this is actually horizontally compressed, right? This is horizontally compressed. Like here's your normal. I didn't do that, it's so great, but it takes until 2 pi to do the sine function, right? So it's compressed it and it's stretched it out vertically on that. Now let's do one with actual phase shifts. Notice you have a C here. So A sine bx minus c plus d. So our b is 1. Our c here is 3 pi fourths. Our amplitude is just the 1 in front of the sine. So the absolute value of 1 is 1. Our period is 2 pi over b, so 2 pi over 1. Our phase shift, c over b. So our c here is 3 pi fourths, our b is 1, so this is just 3 pi fourths. So our key points, we're going to start at 3 pi fourths. So this is moving it, it's positive. It's moving off of 0, it's moving it to the right 3 pi fourths to start the cycle, if you will. Okay, and then what we're going to do is we're going to cut the period in fourths. Whoops, 1/4 of our period, and we'll go up 2 pi fourths. We'll go up pi halves. So the next point would be 3 pi fourths plus pi halves. Well, that's the same as 3 pi fourths plus 2 pi fourths. So the next point is 5 pi fourths. And then we'll go up another pi halves from that. So 5 pi fourths plus another 2 pi fourths, 7 pi fourths. And then up another 2 pi fourths from there. In other words, up another pi halves from there. 9 pi fourths. And our last one would be 11 pi fourths. And those are the points that you want to plot. Those are our key points. Those would be really nice points on our graph. Let's see if we can't graph this thing. So again, instead of starting at 0, I'm going to start at 3 pi fourths. And then I'm going to go up pi halves from there. So 5 pi fourths would be a nice one. 7 pi fourths. 9 pi fourths. The last one I want to plot is 11 pi fourths. Now let's throw in the 3 pi fourths. So 3 pi fourths goes in for x. And so we got 3 pi fourths minus 3 pi fourths. Well, that's 0, and we know the sign of 0 is 0. There's our, quote, starting point, if you will. Okay. Now let's throw in the 5 pi fourths for x. So 5 pi fourths goes in for x minus 3 pi fourths. Well, that's 2 pi fourths. Well, 2 pi over 4 is just a pi halves. And we know the sign of pi halves is 1. So 5 pi fourths, comma 1. And then we'll throw in 7 pi fourths. So 7 pi fourths minus 3 pi fourths. So that's 4 pi fourths or 1. And I know the sign of pi is 0. And then I'll throw in 9 pi fourths, and it'll spit out negative 1. Then I'll throw in 11 pi fourths, and it'll throw out 1. So your midline's still at y equaling 0. Now this keeps going, and this keeps going, right? You could graph more of that. But what I want you to see is that how long did that take you? That's still a period of 2 pi. This period is still 2 pi, but it was shifted over, right? The graph was shifted over. Instead of being, like this, I didn't draw that the greatest, but it's kind of like that. That's the original sine function, right? It still takes 2 pi to do it, but it's been shifted over 3 pi fourths to the right. That's what that phase shift does. Moves it over. This is not a bad one to say, hey, I want to try this problem. If you want to make this a U-try problem, that'd be great. Number 1, I would say, hey, my amplitude is the absolute value of 3. This is a cosine bx minus c plus d. So the amplitude is 3. Our period here is 2 pi over b. So 2 pi over our b here is the 3. So 2 pi thirds is our period. Our phase shift is the c value, which is pi halves, over the b value. So again, that's pi halves our c. Our b here is 3. So make that a 3 over 1 and multiply by the reciprocal. So it looks like our phase shift, where we want to start these key points, is at pi sixths. Okay, so I want to start picking pi sixths. That's my first one. Then I want to cut this period. Now notice my period is 2 pi thirds. Cut it in fourths. A fourth of 2 pi thirds is 2 pi over 12. Well, 2/12 is 1/6. So I want to go up by pi sixths. So pi sixths is my starting point. What's pi sixths plus that pi sixths? Well, that's 2 pi sixths or pi thirds. 2 pi sixths plus another pi sixths, 3 pi sixths. Well, that's pi halves. 3 pi sixths plus another pi sixths is 4 pi sixths. Well, that's 2 pi thirds. 4 pi sixths plus another pi sixths. 4 pi sixths plus another pi sixths is 5 pi sixths. And that's all I need. That'll show me one cycle. And let's throw in, let's see, what was our original? Y equals 3 cosine 3x minus pi halves. And I'm going to throw in the pi sixths. So 3 times pi sixths minus pi halves. Well, 3 pi sixths is pi halves. That's pi halves. So I got 3 times cosine of 0. Well, the cosine of 0 is 1. So I got 3 times 1 is 3. So I'm at pi 6. Let me keep going. Pi thirds. 2 pi thirds. 5 pi 6. All right, pi 6 we got 3. Okay, here's our start of this thing. I'm going to throw in pi thirds now. So 3 times pi thirds minus pi half. So I got 3 pi thirds, which is pi. Pi minus pi over 2. Well, that's 2 pi over 2 minus pi over 2. That's just a pi over 2. So the cosine of pi over 2 is 0. 3 times 0 is 0. So we get pi thirds 0. I could punch in pi halves. It's going to spit out -3. Punch in the 2 pi thirds. You're going to get 0. And you can punch in the 5 pi 6. You're going to see your cosine function with that period, because this has been horizontally compressed because that b value is bigger than 1, right? And it's been stretched out because that amplitude is 3, right? That's vertically stretching that thing. And so here's a pretty good look at this function. Let's look at a few more here. This one we've got sine. So y equals a sine bx minus c plus d. So this has been vertically compressed because the amplitude is just a half here. So number 1 amplitude is a half. Number 2, our period is 2 pi over the b, which is pi. So 2 pi over pi is just a 2. Our phase shift, see how this is a plus, so our c is actually negative pi over our b, which is pi. So our phase shift here is negative 1 on this thing. So our phase shift is negative 1. That's where I want to start plotting points, is at -1. And then I want to cut the period. The period is 2. I want to take a fourth of that period. So 2/4 or 1/2. I want to go up by a half. So -1 plus a half, negative a half. Negative a half plus a half, 0. 0 plus a half, 1/2. 1/2 plus a half, 1. I want to plug those in 1 by 1. Let's plug in the -1. And we got negative pi plus pi is 0. I know the sine of 0 is 0, so I got a half times 0 is 0. I could plug in negative a half, and I'd get a half sine pi times negative a half. So I got negative a half plus pi, so that'll give pi over 2. And I know the sine of pi over 2 is 1, so I got a half times 1, which is just a half. And I could plug in these other ones as well. And then we could start graphing this thing finally. So we're starting at -1, and we're going up by a half. So the negative a half, then 0, then a half, then 1, and this will show us one whole cycle of the sine. Negative a half, and then negative a half, comma a half, 0, 0, 1/2, comma negative a half, and 1, comma 0. And the midline is unchanged. Of course, this keeps going. So your domain is all real numbers. Your range, though, only goes from negative a half up to positive a half on that, right? We did graph a period there. All right, number 1 here, our amplitude. That's the value -2. Now notice that is a negative value, so that's going to flip the cosine over the x-axis, right? Our period here is 2 pi over b, which is 2. That's the 2 right there. So our period is pi. It'll do one cycle every pi amount. Our phase shift is c over b. Well, if you notice, this is a plus, so the c's got to be negative pi thirds over our b, which is 2. So negative pi 6 is our phase shift. So you'd want to start at negative pi 6. And then we cut this period into a force. Our period is pi, so pi force. So we're going to go up pi force from negative pi 6. So let's do that. Negative pi 6 plus pi force. Let me get a common denominator of 12. That's negative 2 pi 12ths plus 3 pi 12ths. So the next one is pi 12ths. And then I want to go from pi 12ths. Again, I want to go up a fourth of the period. So from pi 12ths up pi force again. Well, pi 12ths plus 3 pi 12ths is 4 pi 12ths. Or pi thirds. So there's our next one. So 4 pi 12ths plus another pi force will give you 7 pi 12ths. 7 pi 12ths plus another pi force give you 5 pi 6ths. Okay, and then we'll throw those in one by one. Let's throw in the first one. We got 2 times negative pi 6. That's negative pi thirds. Plus pi thirds is 0. And we know the cosine of 0 is 1. So we got negative 2 times 1 is negative 2. Let's draw this thing. Negative pi 6 gives us a value of 2. There's our starting point on the cosine. I plug pi 12ths in, you're going to get 0. Plug the pi thirds in, you're going to get 2. So pi 12ths about right there. And then you've got pi thirds, 7 pi 12ths, 5 pi 6. Okay. Pi 12ths 0, pi thirds. Oh, I graphed that first one wrong. I'm sorry. That's pi thirds negative 2. Or, I'm sorry. Negative pi 6 negative 2. Here we go. Right there. Start right there. Negative pi 6 negative 2. Sorry about that. Pi thirds 2, and then 7 pi 12ths will spit out 0. 5 pi 6 will spit out negative 2. And you'll have cosine function. Again, that period here is pi amount. Amplitude is 2. Right? Another one before we find equations from graphs. A sine bx minus c. So number one, our amplitude is 3 on this, and our period is 2 pi over b. And I should say, you know, if it's negative, you can ignore that, because what this is doing is just reflecting it about the x-axis. Okay, so you've still got a period of pi here. Your phase shift, c over b, the c here is negative pi halves, the b is a negative 2, that over 1, so times negative 1 over 2. You got pi over 4. And so that's where we want to start. It's moved it over pi to over pi 4. So instead of the 0, 0 as your classic sine starting point, this is moving it over. We're going to start at pi fourths. Okay. And then we're going to cut the period 1/4 of the period. So up pi 4. So pi fourths was pi fourths, 2 pi fourths over pi halves. 2 pi fourths plus another pi fourths, 3 pi fourths. 3 pi fourths plus another pi fourths, 4 pi fourths. 4 pi fourths plus another pi fourths, 5 pi fourths. And then we'll plug those in one by one. you can kind of see that. And I also want to point out another way to write this. If I took a negative out, I would have 2x minus pi halves. Okay, so this is saying that's a reflection about the x-axis, and then I'm moving it right pi fourths from there, right, with a vertical stretch from there. Or if you remember, sine of negative x is negative sine of x, you can also write this as negative 3 sine of 2x minus pi halves. This is the same thing. So that's another way to think about this. Okay, you can think about it reflecting, instead of reflecting about the y-axis like I was saying right here, right? Flip the whole thing around the y-axis. You could say, well, if I use the fact that the sine function is an odd function, I can reflect it about the x-axis and then shift it c over b, right pi fourths to start out. So that's another way to do that. But let's go ahead and move on with these last few here. And let's take a graph. Okay, and here, is this a cosine or a sine? That's kind of the first thing I'm thinking to myself. And I'm thinking to myself, well, sine, I'm gonna go with the sine because I start at 0, 0. So I'm gonna use the sine, okay, first of all. And then I'm going to know, well, my amplitude, see how it goes as high as 2, as low as negative 2. So my amplitude is 2, right? And it does start out increasing. Amplitude has got to be 2. Starts out increasing. So it's not like it's flipped it over the x-axis or anything. So the only other thing I got to think about in this case is, what's my period? How long does it take to do one cycle? Well, it looks like it takes 4 pi is my period. So since the period is 2 pi over b, and I know that it takes 4 pi to do that, let's solve for b. So let's multiply both sides by b. So now we got b times 4 pi equals 2 pi, and let's divide both sides by 4 pi. So b equals a half. So then I'm like, okay, a sine bx. I know my a's got to be a positive 2. My b is 1/2. So I got a sine of 1/2 x, or x over 2. And that's my equation for that one. Let's do another one. Now this one, notice it starts out at 0, negative 5/2. Hopefully you're thinking about, okay, well, I remember the cosine, or at least that's how I think about the cosine. It takes 2 pi to do that. Starts at 0, 1. So if I flip that over, that would look like a little more like this one, right? I flip it over. So I'm thinking, all right, let me use the cosine here. But what would my amplitude be on this thing? Well, the highest it gets is 5/2. The lowest it gets is negative 5/2. So the difference is 5 minus a negative 5/2, 10 over 2, or 5. Right, but it's half that, so it's just the 5/2. There's my amplitude. So the amplitude, is it 5/2 or negative 5/2? Well, hopefully you notice that it flipped it over. All right, took that original point, flipped it over. So the A is actually a negative 5/2 on this, because it's reflected at about the x-axis. And then the second thing you want to look at is, all right, how long does it take to do a period? Looks like the period here is 2, right, to get there, right? 0 to 2. So the second thing is, well, since I know the period is 2 pi over b, my period is 2, let me multiply both sides by b, so I got 2b equals 2 pi. Now let me divide both sides, so it looks like my b is pi. So here's what we got. A cosine bx my A is negative 5 halves. I flipped it over and I have an amplitude of 5 halves, and my B is pi. So negative 5 halves cosine of pi x. I think I got one more here, and we'll call it good. This is a good one to test yourself. Great time to pause it. All right, hopefully you notice that this goes from negative 2 up to 4. That's a distance of 6. So your amplitude is going to be 3, but that changes your midline on this. So your midline is going to be at y equals 1, right? So it's bumped the whole thing up 1. So that's your D on this. And then I'm thinking to myself, well, it's kind of like the cosine. You know, cosine looks like this, except I got to flip it over. All right, so it's more like this. All right, so my amplitude, which is 3, right? My amplitude is 3, but is it positive or negative 3? It's got to be negative because I got to flip that point over on the cosine. So my A is negative 3. My amplitude, of course, is 3. And then the other thing I'm looking at on this is what's my period. So if you can see how this period, it goes from here to there, right? It takes 3 halves to get there. So since my period is 2 pi over b, my period is 3 halves. Let me get my b on top. So I got 3 halves b equals 2 pi. Let me multiply both sides by 2 over 3. And we've got our b here is 4 pi over 3. And now we can write it. We have a cosine bx plus d. Notice there's no phase shift on this thing. Our a, we had to flip it over. The amplitude was 3. Our b is 4 pi thirds x, and then the whole thing was shifted up 1. The midline moved up from y equals 0 up to y equals 1. And hopefully that's enough to kind of get you going with this graphing. And I sure appreciate you guys sticking with it today. See you next time.